All right, up next, let's talk about the AO shader node. So we'll pull that guy up and drop it in. And let's go ahead and pipe it out to the surface. So an easy way to think about AO is imagine that you have a big sky around your whole scene. And for every point on the geometry, let's say we're talking about this point right here, it's going to say, hey, okay, let's look around and see if we can find the sky. Okay, this way I can find the sky. This way I can find the sky. This way I cannot. This way I cannot. Okay, so let's take those samples we just took and average them together. So I'm going to be like kind of dark because I can't totally see the sky. Whereas the point over here can pretty much see most of the sky. Whereas a point up here, for example, or a point way back here can see the whole sky. So they're going to return white. And the effect this gives is one of almost like an overcast day, for example. So let's jump into the settings and see how we can make this useful for us. All right, so initially, if I just take a look at this guy real quick, you'll see we're very, very noisy. That's because right now I'm at a very low max sample, and the camera rays on their own aren't enough to resolve these shaded areas. So what we can do is throw more samples at it. Let's say 128, and picture viewer that guy. Now we can see it's very clean by comparison. Now we've still got some grain in there, so you might want to kick it up to like a 256. Anyway, samples is essentially, hi, I'm AO, please sample me more. Actually, let's keep that at 64. Let's keep that at 128 for now. So now we have bright color and dark color. So bright color is what we see as brightness here, and dark color is what we see as darkness in this image. And remember, we have no lights or anything in the scene. We're just strictly looking at the AO output. So we don't have bounce lighting, we don't have anything. So you can see when I change the bright color, most of the scene changes its color, except for the darkness areas. And we can even say like, hey, maybe let's not make those darkness areas. Let's make that a blue. And sometimes giving it a look in this way can actually help you realize how much AO calculation is happening, because when we look at it in black and white, our brains tend to gloss over some of these areas that we just expect to see shaded. So this actually looks pretty cool for now. So I'm actually going to leave it. All right, next up is spread. So if we imagine for a second, wait, let me change the color of this guy. Something we can see. How about white? That looks good. So if we imagine our point that we're going to sample, and we say, okay, I can see sky this way, I can see sky this way, I can see sky this way, I can see sky this way. Ooh, bonk. Nope, can't see sky. Bonk. Nope, can't see sky. Essentially, what spread is going to do is narrow this cone that each point, or to be more precise, each pixel is looking for. So as we decrease our spread, our angle will narrow. And if we narrow it enough, this point that we were looking at will only see sky. So if you think about that now for, let's say, this point versus maybe a point a little farther out, as we decrease our spread, this guy is going to see all sky before this guy. And if you put 2 and 2 together, you'll realize that that essentially means that it's going to tighten the shadow. So let's go ahead and walk this down. Let's like give it half. And now you can see if I pop this guy into the picture viewer, and let's go back up to 8 and picture viewer again, you'll see that our farther out points are no longer being occluded by the objects, and we're getting full red pixels out here. So you can think of fall off as an intensity for your AO, which is really just a bias between the occluded and unoccluded areas. So if we have 1, we are unbiased. If we go under 1, it's going to bias more toward unoccluded, or the bright color. And if we go over 1, it's going to bias more toward the occluded, or dark color. So let's flip that back to 1. And then for max distance, let's go back to Raytown again. So right now, this point in the middle between the box and the sculpture is being occluded in both directions by both objects. But it can still see out this direction, which is why we're this purplish color in the middle. Now, max distance is just going to say, okay, here's how far your rays can travel. So at a point, we'll reach a threshold where if our max distance is low enough, the ray is not going to make it to either object, and that part will brighten up. So let's go ahead and say our max distance is going to be 10. So as we predicted, this spot in the middle is now perfectly bright because the rays can't reach far enough to see either one of these objects. And effectively, this just shrinks the occlusion down. All right, I'm going to reset everything. Actually, why don't we just bring out a new AO shader? Okay, if you're seeing colors in this white right now, it's because you've been staring at that red and blue for the past minute or so, and your eyes have to readjust to what white is. Anyway, all right, let's go ahead and move on. So reflective is pretty cool. When we tick reflective on, it's going to use that same process of casting the rays per pixel, but in this case, we're going to find objects to reflect. So if I actually take my spread down, if you remember, spread is kind of like a cone angle for each sample. If we bring this down to 0, it should look perfectly glossy. And the reason for this is that our cone angle is based around our surface normals, which in the case of the box look like this. For our ground plane, look like this. And we've reduced our cone angle around these surface normals down to 0. So they're just perfectly casting rays straight out of their surface normal, which more or less is precisely what a mirror would do. Now as we start to increase that spread just a little bit, okay, let's maybe do like 0.01. There we go. So now we get blurry reflections because instead of just casting straight along our surface normal, we're also casting a little bit of a cone. And this returns inconsistent values across the entire surface, and that causes the result to blur or look rough. So it's actually kind of fun that you can get this model just with the AO shader. Let's see, invert normal. Not really sure why anyone would ever use that, but you know, never know. All this is doing is saying, okay, remember how we were casting all our rays this way and this is our surface normal? Well, now instead we're going to cast them the opposite way. So like the box is casting inward, or this point is casting inward on the sculpture. So let's take that guy off and put reflective back on just for a second. And now we're going to look at output mode. So output mode, instead of using just a pure white sky, quote unquote, we can actually use an environment to sample. In this case, I've got a dome light in the scene, and we're going to go ahead and use that. All you have to do is just have a dome light in the scene and turn it on. And now you can see we're getting this reflection effect from the environment instead of just like a white sampled sky. And if we flip spread back down, it should be perfectly mirror-like. So let's go ahead and tick reflective off for a second. And we'll bring spread back up to 0.8, which is the default. So now you can see with reflective turned off, we're getting essentially a single bounce of diffuse light, indirect diffuse light. Of course, it's extremely grainy because this isn't using importance sampling and various other optimizations, but it's still kind of neat that you can do all this through just the AO node. Okay, let's bring another new AO node out and just finish this off. So consider same object only is kind of interesting because the rays are only going to evaluate occlusions made by each object onto themselves. So our boxes, you can see, totally disappear or are perfectly white because they're just straight looking out at a sky. Our ground plane is perfectly white because it's doing the same thing. And the only thing we see shading on is the sculpture because it's occluding itself from the sky. So lastly, we have bias mode, and this one's actually pretty interesting as well. Bias mode, when you initially turn it on, it's going to do nothing because you have to tell it a direction, and that's exactly what this vector input is. So if we bias, hang with me just for a second, if we bias in the positive X direction, let's just look down at our little orientation duder down here. So X is running this way. So if we bias our AO in the X direction, you're going to see it's like it's shooting the occlusion rays with a bias of 10 in the positive X direction. If I flip this down to 1, you can see that the rays aren't looking nearly as far because my vector decreased by 10 times from 10 down to 1 in the positive X direction. Similarly, if I set -1, you're going to see that it comes in the negative X direction, or if we set -10. Okay, so here's a kind of cool thing. If instead of using world space, we use object space, initially everything's going to look the same. But instead of using -10 in the world space X direction, it's now going to be in the -10X object direction. So if I start moving my object around, actually it won't work on this object. It would needs to be the surface that the rays are being evaluated from. So actually if I wanted to turn, I need to turn the ground plane. So now we should see that our cat looks exactly the same. It's just that all of the evaluations being made on the surface of our ground plane have been oriented according to the object space rather than the world space. So if I were to take my sculpture here and turn it, we should see the shadows on it. Well, it's probably going to be impossible to see. Maybe if we like look down over here and I just turn it a little bit, it's kind of hard to tell. But essentially we're doing what we were doing with world space, except on a per object basis. So you're probably thinking, well, that was cool, except I zoned out like 2 minutes ago. When am I ever going to use any of this crap? Well, I find it can be useful. For example, if we had a standard material here, let's flip this all the way up to white. Whoops, that's not white. And let's kill our reflection and maybe up our samples a bit. Okay, so one way this can be useful is, let's say we feel like this box touching the ground plane, like, crap, I can't see it enough. Maybe let's turn our dome light so it's kind of bright on this side. Yeah, man, I can't really tell where the box and the plane come in contact with each other. And maybe it even looks a little too bright. So what I could do is, I've got my AO shader. Just take a look at that. What I can do is say, well, why don't we pump that into maybe the diffuse color, and then we'll pipe that out. So now, I mean, I think this is way too dark, but now we've like darkened that forward-facing edge, and we can just come into our dark color. Let's flip this over to HSV and dial it in to something that's maybe a little bit more reasonable looking. So if I picture view this, dial that back in, and just gonna move this off to the side for a second, and we will get rid of our AO out, and we'll picture viewer that. We can see that we've just added a bit of shadowing into the scene that we otherwise wouldn't have had. We could also, let's just look at our AO for a second again. Let's go turn it all the way black again, but let's make it really tight, so maybe a max distance of 10. And let's bias it in the direction of the occluded color, so maybe like a 3. Maybe like more than that, like a 10. Maybe let's also bring our spread down a bit. Okay, that's good enough. And so let's say I've got my diffuse surface here, and I'm just gonna control drag it, make a second shader. Let's just use the gold. Oh man, why don't we just leave it like that? Looks great. So we'll drop in a material blender, and we're just gonna say, cool, that base color is gonna be the white diffuse that we had. And we're gonna have a second layer that is our gold color. And let's just check to make sure that works. So if it's white, it should be all gold. If it's black, it'll be our diffuse. And we're going to pipe our AO shader into that blend color, except I want to invert it, which is super handy to not have directly a invert button, but that's okay. We could simply just flip our colors, and now we're blending these two materials together using the AO amount. So maybe I'll dial our spread all the way up to 1. Ooh, we could try blending by the reflective amount. That's interesting. So yeah, you can do all sorts of stuff with the AO shader.